So I think the most important thing about the arculee is, of course, the increased load capacity. At the same time, it has the footprint of a pallet.
What are the different types of backpacks and stations currently available, and how do their functionalities differ?
So the reason for backpacks is to have a variety of use cases, so that we have our customers, they have pallets. Pallets can be transported lengthwise and crosswise, depending on the desired use case and the layout of the factory. So with those backpacks, we have the possibility of adapting our robot without getting another variant of the robot, but just adding another backpack on top.
How does the arculee M's mechanical design ensure compatibility with various backpacks?
So the mechanical design is in a way that we have a universal interface between the base product and the backpacks. So we have the same mounting positions, the same interface electronically for all the backpacks. So then the base product of the arculee M never needs to change, and all the backpacks are compatible.
How does mechanical design ensure durability and ease of maintenance, especially considering the environments the robot will operate?
So of course we know that these are being implemented in very industrial situations where things can get knocked around and needs to be very robust as a product. And also when it comes to serviceability and maintenance, we keep that in mind as a requirement when we're developing the product, to make sure that, for example, service technicians in the field have access to all the components and don't need, let's say, additional tools to maintain the product in the field.
What are some key considerations when ensuring seamless integration between the robot, its backpack, and the stations?
So I think that's one of the strengths of Arculus, that we are very close to each other. So we have the production in the same building as our software development, as the hardware development, and we're talking to each other constantly. We're sitting in the same office, we're meeting at the coffee machine, we can talk about topics, and then we have those sprint reviews that we have every 2 weeks, so we can see what the others are working on, which ensures feedback to those teams. And at the same time, on the PO level, we have daily alignments on topics we're working on, so that we can make sure that we are all working to the same direction and have the same focus.
So it's not like there are segregated departments that are just working in their own directions, but we're all kind of working together on the product as the final goal. And I think that's really something special at Arculus here.
What does the design and development process for a new product typically involve?
Typically, it starts off with really a conceptualization phase based on the requirements for the product that we were talking about earlier. And this is usually we're basically trying to meet the functionalities with any concept possible. Once we have a couple of concepts, we typically do some sort of decision matrix to determine what's our best way forward. And then we go into a detailed design process. And during this whole time, of course, we're keeping in mind the functional requirements, but also the technical specifications of the product. And yeah, that's how we make sure that the product works.
How do you ensure that new products meet both technical specifications and user needs during the development process?
So I think a very important point here is that we are all involved in testing our own products. So we have a testing area set up in the building, so everybody, also the developers who do mechanical design, they can go there and test their own product. So this is the very first step. When we have a proof of concept or a prototype, we can go there, test it, and see how it feels, how it works. And then in the next stage, we have pilot phases in our internal factories at Jungheinrich, where you can get the customer feedback there before we roll it out to the external customers.
Another point to add there is, the technical specifications that we define for our new products are typically coming from the use case and user needs. So we really try to think about, for example, what is the performance that our customer requires or would like that would be competitive, and that would then be translated into a technical specification for our product.
Maybe also one thing to add here is that we have those very small cycles, like intervals of iteration in the sprints. We can always, when we see it's going to the wrong direction, we can change our path. So when we're seeing, hey, this didn't work out as we planned, we can say, okay, we're going to leave it as it is and do something else. So we're very flexible there.
Were there any specific components or systems that required extensive testing or redesign?
So we just recently had this one issue where we changed the method of navigation, which was a big change for a lot of products. So we had very close collaboration with our software team and to align on the visual detection of, for example, our handover stations, which meant we had to iterate our station design, which had quite a big impact on the overall product.
Was there a point where you had to balance mechanical complexity and functionality or cost? And how did you navigate this?
I would say that mechanical complexity is a result of balancing functionality and cost, actually. So as a mechanical design engineer, or any type of engineer really, when you're designing something, there are several, or let's say 3 main factors. There's cost, there's time, and there's quality. And depending on which of those 3 factors are the priority for the project, then results in how complex the system will have to be and the functionality, of course. That's essentially the day-to-day work that we're doing, is trying to balance and manage these 3 factors of how can I design something that is cheap, but also, let's say, complex enough to achieve the functionality that we require there.
You might also need to consider the stage that the product is in. Like when you have a very early stage, you just want to have a proof of concept. Maybe costs are not the highest priority at this stage. Once you have checked that it's working the way you want it to work, then you can move on to the next stage and optimize it for costs.
Can you discuss the process of creating custom designed backpacks for specific customer needs?
So we get those inquiries from the customers quite often. They have their specific, let's say, pallets or load carriers. So first of all, we need to make sure that we have the complete data that we need. We need to know how their plans, their sites look, because we need to check also like driveways that we can drive through. And once we have all that data, we have to like either redesign those load carriers or get the CAD models from the customer. And then we can check if we can like carry those load carriers with the existing portfolio. Because of course, for a company, it doesn't make sense to spread the variety of components too much, because we would like to have it as least as possible parts. But if necessary, then there would be a customized design for that specific load carrier.
How does each of you view the most impactful functional improvements in the arculee M compared to the arculee S?
So I think the most important thing about the arculee M is, of course, the increased load capacity. So we have the 1.3 tons load capacity. At the same time, it has the footprint of a pallet, because we see the arculee M as or the main use case of it as a carrier of those industrial pallets and Euro pallets. At the same time, it has a higher capacity, or it has increased compatibilities to load carriers. We can transport pallets lengthwise and crosswise, which wasn't the case with the arculee S. So I think that it has a very high focus on pallet transportation, which makes it very versatile.
Yeah, the assemblability, the serviceability, the simplification of the design itself. So we made some really big strides from the S into the M design, where we really focused a lot on making sure that this thing will last a long time, and if it needs to be serviced, that it's easy to service for our technicians. Lots of improvements in general performance, let's say, so that we can be sure that this product will be lasting a long time in the field.
Can you discuss a specific functionality that you personally worked on or found challenging?
There's a lot of complex assemblies inside of the product. One of the challenges is to basically find a solution that can withstand the forces and the dynamic conditions that the product will be experiencing in the field. So it's for example, the lifting system, it's not simply just lifting something up and down, but we also need to reinforce the system from braking forces or centrifugal forces when driving in curves and things like that. And we made some very big strides on the design of how we provide this robustness to our product there.
How did your approaches differ during development?
Yeah, I guess during the development time, of course, we were working very closely together. We were really focusing on meeting the requirements for things like making sure it can lift fast enough, like making sure it can travel fast enough, but we weren't, or I wasn't myself so far in depth with how we're transporting load carriers and, you know, the whole backpack floor station aspect of it.
Thank you so much for joining, Fabian and Linus. See you in the next video.